Hello everyone. We will discuss about reliance and dependence of building design on energy. Like how energy is involved in our buildings and how much saving can be done and how much is consumed by which area, which particular component of the building. So we will see one by one. So if you see this particular table over here, so this talks about the total cost invested in any given building. Okay, in a normal condition, and what happens in the a green building condition on the the lower color actually band you can see. So the top one, okay, it talks about if the total building cost is divided into 100%. Okay, so the almost 30% is taken by the structural systems. Okay, almost 15% is taken by the electrical systems. Okay, almost 30% is again taken by the architectural systems, and rest of the 25% is taken by almost mechanical systems. So in that, if we go for any such measures of this green building efficient measures, okay, so the percentage what we see is is saved from electricity and in the mechanical consumption is significant. So as we can see, the transfer which happens from electrical to the architectural aspects, okay, so the cost actually gets reduced by 5%, almost 5% over here, and in the mechanical portion it gets a reduction of approximately 10%. So but overall what we can see in the savings over here is up to 15%. So 15% I think is not a small actually volume. Okay, and if we consider the same thing for almost every building, okay, if we turn our regular buildings, our normal buildings into a green buildings, so at least 15% of efficiency, 15% of improvement is can be made on the costing. So for any investor, okay, for the any financier who is putting in his wealth for the construction of a normal building, okay, from normal to actually a green building, then she is observing a 15% actually benefit. Okay, so that benefit on the a monetary terms is huge. 15% is a very good cut. So how the building costs can be reduced, okay, through going for a green design actually principles. So this is given from this actually table over here. So how these green things can be achieved? So we have discussed earlier, net zero energy buildings are the one concepts where a building can go independent of the a normal a national grid or state grid and generate its own a power for meeting its own demands. So if we see in the non-industrialized non-industrial countries like ours, which are still not in the league of the advanced countries, so how these actually efforts can result into some advantages. So let's see if there are a long-term goals, if there are a middle-term goals, and if there are a short-term goals. So how this whole phenomena will unravel, that we will see over here. So let's start with the bottom one, short-term goals. So with the common vision of the industry, government, professionals, local community, the other institutions, okay, so this can be actually set. The best practices such as bioclimatic and passive designs, those strategies can be involved in the a building design to reduce the first of all the consumption of the electricity in any given building, so that the overall requirement of the power remains under a check. The third one, improve interior air quality, so that the efficiency first of all of the occupants or the inhabitants of that building will improve, and the overall actually load on air conditioning or improving the air quality will also get minimized. The fourth one, development of a local comfort model. So generally we follow tools and graphs and the given actually standards which actually run at the national level, but this is actually needed some intervention to generate and to create actually such parameters at the local level, so that we have actually the model of the local comfort level, like how much of variation is need, how much of variation is going to be there in the temperature, in the thermal range, how much in the like a humidity, how much in the like a precipitation, how much in the like a wind speed, wind velocity. Okay, so accordingly we can actually take care of. So it's like actually making our buildings suitable and relevant in any like a given like a local condition, the microclimate what we call it. So like a particular state in India generally has like a one or two types of like micro climates. So in that climate also there are like a smaller like areas which follow certain kind of like a microclimates. So we should have actually templates, we should have standards, we should have the data actually to meet actually such microclimatic actually conditions, so that the buildings can also be designed accordingly to maximize the actually local conditions of the climate. The next one, promoting energy efficiency and renewable energy technologies. Well, of course, it's a proven actually fact these days. If we promote non renewable energy, and if we promote like a renewable energy like sources, so of course the renewable energy sources are like a infinite. Okay, they can be harvested like as long as we want. Okay, they are not going to last. Plus, they do not have like the bad kind of like after effects and side effects. Okay, they do not have like a much impression of like the pollution or the CO2 emissions or any sorts of like emission. Okay, so of course they are cleaner than the conventional non-renewable energy resources. So these techniques, these technologies can be employed in our like buildings. The next one talks about low-tech industrial infrastructure. So very high technology actually industrial infrastructure takes a lot of investment, a lot of cost. Okay, it needs to like maybe like a import like a several technologies, several equipment and tools from like a far away places. So why not to go ahead with the low-tech technology which is local, which is regional in nature, and utilize that itself on the site. The seventh one talks about development of baseline models. So assess energy and environmental building performance. So if we create one actually base model, okay, or a base case for like a one building which gives us like a optimal performance on like a energy harvesting and energy utilization, so that model can be emulated in that actually microclimatic region. So that will become as a role model that will give a lot of like a data in terms of like how to go about how to detail these buildings, what are the materials to be used, what are the forms to be followed, how to handle with the orientation, how to handle the sizing and scale of the building. Okay, so all of these actually strategies will become handily available for the local architects and designers and engineers to implement in their projects. Let's see like what are the midterm goals for achieving like a such efficiency. So this one talks about like maximizing performance of low tech industrial infrastructure. So the low tech infrastructure what we spoke on the previous one, okay, it talks about like a maximizing the performance of it, so that we can make like a maximum use of actually such a facility which is rightly available in the like a nearby like a region, in that particular given region. The next one talks about introduce high-tech solutions. So even if we are following like a low-tech industrial like infrastructure, but we can go for like a high-tech solution, the high technology solution, because importing the technology from elsewhere is not going to cost us like in terms of like a resource consumption. So we can utilize the resources from the local. The still we can import the high-end technology from like elsewhere. So the technology itself can be imported from elsewhere, and by using the local means and the materials and resources available, we can maximize the actually benefit. So that is the purpose over here. The 10th one talks about development of database for building carbon footprint, such as like a materials and services. So how much carbon footprint these individual components are exerting. For example, like construction materials such as like bricks, steel, glass, the tiles, several other like paints, other like a partition materials, other like a fibrous, the boards, etc. There are several types of like binders, other compounds. So all of these put together, as well as the materials which are utilized for like building services such as like lifts, fire, water supply, sanitation, plumbing. So all of these like materials can be actually divided into their unique components, and can be assessed for creating like a database of like a building carbon footprint. So how much carbon is being emitted from like a one unit case actually building. Okay, so that can be actually developed as a standard case model. The next one talks about include a minimum target for renewable technologies plus energy and efficiency. So at least every actually project should set a target of actually utilizing like a renewable actually technology, renewable like energy, because only with the help of that target, okay, the team can actually strive for actually achieving that target, and we can actually achieve like some success in that. The next one talks about standardized low-tech news net zero energy building. So zero balance by heating and cooling. So how we can actually minimize the differentiations. So how we can maximize the uses of like a, and the temperatures or the the resources available right outside the building. So the overall balance actually remains as close to zero as possible. So that is the actually purpose. So how like these the natural actually phenomena can be actually employed in the like a design of the building. The 13th one talks about minimum objective for connected loads. So like the connected loads should be actually kept at minimum. So the design load, if it is like a lower, so the overall actually planning for the like energy consumption will always lower. So we should actually work out the entities and the artifacts and the articles which consume actually lesser energy. The 14th one talks about a target net zero energy building for existing buildings. So even we can employ this net zero energy building concept even the existing actually buildings. So why not to go and redesign actually the power infrastructure, the power actually requirement of these buildings, and arrange for actually energy generation on site itself. So that could be actually a mid-term a feasible plan where this can be implemented in a shorter span of like a few years. Okay, and the building can be like taken over from the like a main grid to the actually local this microgrid or the on-site itself. And 15th one talks about measurement of the interaction with the energy grids. So the connection from the main grid also should be there in case like if building falls short of the like a power requirement, or if it generates like a surplus energy, that can be given back to the regional or national grid. Okay, let's move to the long-term goals. Like how these goals may help us actually achieve the target of like net zero energy building adoption in Indian context. So this one talks about like a high-tech net zero energy building. So the again going for like the long-term investment, if you are talking about, then the high-tech high-level technology adoption will be more fruitful in the longer terms, because that will be more effective, more like optimized actually solutions can be actually achieved through this. So the next one talks about nearly zero emissions, so the 80% of the reduction of CO2 emissions. So by going to like a net zero energy building, we can minimize on operational actually cost and operational actually CO2 emissions, okay, which happen actually out of like a coal based actually power plants, the hydrocarbon based power plants, gas based power plants. Okay, so at least we can register like a huge percentage of actually saving in terms of like emission. So that should be the actually target for like a long term actually plan for net zero energy buildings. The 18th one talks about smart plus low carbon grids. So we should go for smart grids. Well, what are the smart grids? You can maybe Google separately and understand. But these are the actually power arrangements where we work in tandem with the other like regional grids also. And wherever there is like a surplus or deficiency of power supply, the other neighboring grids comes to the rescue and supplies and maintains the overall balance at the national levels. So we can actually devise like integrating with the smart grids to maximize the efficiency. The last one talks about plus energy buildings, so positive balance of energy and CO2 emissions. So there should be actually a balance planned in the like overall like energy consumptions, overall like emissions from that building. So this actually long term actually planning can help establish actually these relationships, so the overall actually impact of the building can be actually minimized. So how this can be done, like this storing the solar energy in the home. So there is one actually paper which talks about such stuffs. I would like to bring it to your kind knowledge right over here. There has been a growing interest in the using energy storage to capture actually solar energy for later use in the homes, to reduce actually reliance on the traditional utility. because solar energy is available in the daytime only. So how can we actually make use of it in the other like a night times and the other times of the day when the sun goes down and sun actually the availability of the sun becomes like a lesser. So, however, few studies have actually critically assessed the trade-offs associated with storing solar energy rather than sending it to the utility grid, as is typically done today. Here we show that a typical battery system could reduce peak power demand by 8 to 32% and reduce actually peak power injections by 5 to 42% depending upon how it operates. However, storage inefficiencies increase annual energy consumption by 324 to 591 kilowatt hour per household on average. Furthermore, storage operation indirectly increases emission by 153 to 303 kg CO2. So as we can see, the CO2, SO2 and other nitrous oxides actually per like a Texas household annually. So this study was actually conducted in this the state of the Texas in the USA. So how this can be done? So they are actually advising this storing facility at the household level itself, so that the dependence and then sending the power back to the national grid, okay, can be also reduced. So the power storage can take place at the unit level of the unit house level only, so that it can be used even in the later times. Thus the home energy storage would not automatically reduce emissions or energy consumption unless it directly enables renewable energy. So this is the actually kind of a provision being advised here by the researcher. Let's see how this happens at the like a city integrated renewable energy for urban sustainability. So here we can see the different components of a building which consume actually how much of power in the like a different times of the like a year. So there are like a two actually charts given over here: the total final energy consumption, okay, and the total actually transport energy per capita. So the lower end talks about the per capita actually, and the above one talks about the total final energy consumption. So as you can see on the top, the table A, the figure A, it talks about the solar hot water. This is the largest actually volume over there, the 240 watt actually thermal per meter square. So this is the actually total energy consumption by hot water actually facilities, and likely if you see there are several other how this can be actually met this demand by the supplier actually group. So at the bottom you can see there are indicators are given with the help of the color codes and the population sizes. So solar photovoltaic cells are able to generate like 120 watts per meter square, okay, and geothermal up to like 100 watts per like a meter square, okay, and similarly there are these like how much is like a wind generates, how much the waste based actually units actually generate, okay. So this is given along with the consumption points also, like how much is like consumed by the the crops and other units. And the second figure you can see over here, okay, this talks about actually the per capita actually consumptions. So how this building management system, the building automation can help to achieve actually such efficient system which we are talking about. So in this one, if you see, we have seen this slide earlier also, this is most detailed one over here. It talks about like installing the HVAC maintenance services. Okay, it talks about installing like a fire detection and alarm systems. It talks about actually security and control system. It talks about actually digital surveillance system. It talks about actually intrusion detection systems. Okay, so with these actually systems there we can achieve like a number of like automations, okay, in the buildings. These automations will help not just in the security and maintenance. These automations will help us even minimizing the energy load and the resource consumption in our buildings. So by installing actually lighting control and retrofitting solutions, we can minimize the energy load. We can install the smooth control systems. We can install actually indoor air quality actually checks. So with that we can switch on and off, and we can keep running our air filters and other solutions for indoor air quality. Okay, we can install like a water management actually information systems. We can install like a energy management information system. We can have our own like on-site technical team and service team, which will keep on actually moving and reporting actually such activities, and if there is any need, they can keep on actually rectifying that. So, and there are several other also new technologies being employed actually, or being used in the like a building facilities. You can see over here they are like environmental control systems. They are the checks for like a mechanical maintenance and retrofitting system. They are like a SL locator. Okay, there are like systems for like a enterprise system integration, where the all of these systems individually can be integrated into one actually system, and can be monitored actually from there. So such actually automation systems can be employed to improve on the energy efficiency part. Let's see how much of like a energy is consumed by a normal like a average household, and a building which is like a designed for like a conserving electricity, and the C actually you can see in this one, the building which conserves energy in construction as well as in the environmental systems. So we can see, I think this is quite evident from here in the case A. If you see, if this building is consuming the 100% of whatever this amount they are the volume of this the amount of energy they are consuming, if it is like 100%, so from this base case of A, so the if you are moving to the case B, energy conserving construction, so in this actually such construction system, we can save like a power by up to like the consumption has reduced to up to like a 64% of the base case. So that's actually a huge actually reduction. That's almost like a more than a 1/3 of saving which is like a done. So that's actually kind of impact on the energy consumption while maintaining, while going for like a energy conserving actually construction systems. And so if you examine the case C, the third one, in this one actually the system follows actually energy conserving construction and environmental systems. So in this it is like observed the energy consumption has stood only at 40%. That means there is a saving possibility of like a 60% which has happened over here. So it's a huge amount of actually saving which has happened over here. Even in this you can see the largest consumer of this energy has remained this domestic hot water system, and then the cooling, and then the office equipment, fans, pumps, lighting, and then comes the heating. So this is actually a pattern which is there in the like buildings. Okay, this is from I think the United Kingdom, but yes, I think it's mostly true in most of the countries. And the actually in the colder countries they work more for the like a heating of the building. In our kind of like a countries we work more for the cooling of the building. But the saving, if we see the overall, remains almost like a significant, very significant. Here if you see like the single largest actually consumer like one component in the building is the space heating. This we have seen earlier also. So the space heating actually takes around 61% of the energy consumed in the building. Then the cooling, and then like a water heating, cooking, lighting, they all have their respective shares. So we can see from here. Okay, and how in this actually figure we can see like a energy performance index EPI before, and in the second one we can see like how it has helped with the like a different like a stage wise, like if we see stage wise of the like a designing and construction of these like a buildings. So how these efforts and costs actually maximize the gains. So in the first one, in this energy performance index, if you see the normal if we go normally as usual, so it stands at like a 1 point. Okay, and the moment we take like a passive measures, it gets down, and it gets down like even further when we go for like a efficient like energy efficient cooling systems and cooling like a the lighting and etc. So there is a significant actually drop in terms of like a the performance of like a energy in that particular like building. And how it actually changes as we progress through our like a concept design, through like a schematic design, then the design development. So if you see like by integrating different like stakeholders, okay, and taking like energy saving like measures, so the efforts and cost can actually come down. Okay, The similar actually integrated design process is given over here also, from the like a concept design to schematic design to the design development up till the like a commissioning. Okay, there is always this potential which is shown over here is the 25 to 40% of like a, this saving potential is observed in this one. So it's a huge actually potential for like a, energy conservation and reduction of the overall impact. And through what are those actually places where this strategic interventions can be made. So we will go component wise in this like a building like illustrations. So the roofing, of course, we can use like a high solar reflective index, like a material that which reflects the heat uh, in the like a outer side, and which doesn't actually heats up the building. So the overall like cooling of the building requirement will be lesser. Then there will be like a steel framing, like a steel is one of the highly recyclable actually materials. So this steel can be used, which can be recycled after the like a life cycle of this material is over. And then yeah, locally sourced material, locally manufactured materials can be actually utilized to actually improve on the indirect emissions part. HVAC systems, well, these can be installed in an integrated manner so that they can take care of the heating, cooling and ventilation actually purposes. Open circulation, that is also can be given so that the open areas can actually take use of like a prevailing wind directions of that actually particular site, and there is no actually much work needed to improve the efficiency of them on the cooling part. Septic systems can be installed on the site. Site grading actually material of the like a natural actually site, the top soil can be maintained. Okay, the drainage can be actually provided in such a way so which actually prevents the soil erosion, which prevents the actually the damaging the top layer of the soil. Okay, which is the fertile one that can be used for actually growth of the grass and other actually plants. South facade can be utilized for actually better like a thermal comfort and this thing, because in the south sun actually goes almost like a vertical, and this side can be utilized for like it's like a strategic purposes. In that on the top side, if you see water well for like a water requirements on the site, or well, this point is actually subjective. It depends on the actually local administration and mandates by the civic authorities. So depending upon the local actually administrative laws, this point can be undertaken. Low maintenance site development, so the site itself should be designed in such a way so that the low maintenance, low mechanical or external maintenance is needed. Okay, and the facade actually the directions of the like a site and the building can be actually taken care of to design the form and the material application in those actually directions. Glazings also can be used for like a depending upon the actually direction. If it is the hotter side, then the double glazing can be used. If it is like a north side, then maybe a single glazing will also suffice. And obviously with the help of the landscaping, the overall ambience and the overall like a UHIE can be reduced significantly by adopting these design strategies over here. Okay, so these integrated like design strategies, they are given some more over here in a very like a controlled building, like a mall, maybe, and a hospital, maybe, or a school or college. So how these energy efficient like luminaires, they can be utilized, and low emitting materials can be utilized. Lighting and thermal controls can be given, and views can be actually given even in the inside of the building, in the courtyard areas, where people can have actually look to the nice ambient actually external site. And the structure can be used with the steel or maybe even like a timber, as in this sketch it is they have used actually the certified actually harvested actually timber. So that comes from the managed forest, and this is one of the actually sustainable practices being adopted in the different countries and economies these days. And making use of the skylight to have access to the natural sunlight in the daytime. Okay, and having actually high performance glazing with the external shades. Okay, and at least providing some view, okay, to the outside, and utilizing actually radiant floor heating or cooling depending upon the climate and location. So such strategies can be utilized for actually bringing in efficiency, and of course utilizing the photovoltaic solar cells and water harvesting, rainwater harvesting actually units, energy efficient equipment, so utilization of these things can be increased for like a strategic, a design inputs in the design of these buildings. And lastly, I would like to mention over here, even promoting like the native species of like plants and bushes and trees should also be encouraged, because they consume like a optimized amount of like a water, and they require little maintenance because they are actually habitual, they are actually native to that place. So a little maintenance will be required compared to the species which is brought from like some other like a regional location, so resulting into like the better efficiency and resource optimization. Like the water is the one actually commodity requires to maintain actually landscaping. So by using actually natural and local species of these flora over here, we can minimize the water consumption using like bioswales, so that the rainwater and storm water actually remains on the site for some time and it percolates to the lower strata. And then yeah, and then using like a LED based actually lighting systems, okay, using actually public transportation, promoting actually individual like cycles, okay, and such things are the actually part of the overall strategy to improve the efficiency. As you can see in this cross section over here of this building, the architect has actually utilized the orientation of the sun to maximize the solar gain on the like solar panels, as well as reducing the solar gain in the inside of the spaces, so that it doesn't get too heated. At the same time, they have utilized this courtyard design to create corridors and walking areas along with some greener facilities. So in context of like India, this is actually sourced from like ECBC, like what they recommend actually for like a different major actually climatic zones of India. So India is majorly divided into five climatic zones: hot and dry, warm and humid, temperate, cold, and composite. So you can see over here the description of these climatic zones are given, and mean temperatures are given in the summer, okay, and winter, and the diurnal variation is also given. And with the help of like this data, actually the temperature chart and the relative humidity chart and the sky conditions and the wind conditions, okay, our designs we can improve on these. So this is actually this actually chart becomes a basis for our planning our strategies for actually designs in these various actually climatic conditions. So even for like a more detailed actually microclimatic conditions, as we have discussed in the previous slide, so we should focus on developing those microclimatic actually charts and data sets for like a better optimization for like suiting these buildings on like a given like location, because even in these like a climatic zones, there are several like variations observed locally from one place to another. Okay, similar kind of efforts in this sketch also over here to improve on the overall performance of the like energy consumption in the building. So there are several like such techniques which can be employed. As you can see in this particular sketch, there is a huge amount of actually greenery given even in the like lower floors of this building to minimize the actually heat load and increase the actually air ventilation, improve the actually air quality, okay, and give a better actually experience to its inhabitants. There are some actually examples from India on of like efficient buildings which have been completed in the recent years, in the last 1 decade or so, and these buildings have become a kind of a landmark for like other architects and designers to follow. So some of these are like to mention over here are this ITC Green Center from like Gurgaon, and Wipro Technologies building from Gurgaon, and Infosys from like Hyderabad, and this is Volvo Eicher corporate headquarters from Gurgaon, and the last one is the Skyview corporate from Gurgaon, and then the second last you can see is the Indira Paryavarana Bhavan from like New Delhi, which I have mentioned earlier. This is the first net zero energy building of India. So these actually buildings are like a worth actually actually taking inspiration from, to how to design like a modern buildings in the like a gaming context, taking help of actually the energy saving, minimizing on the resources, and overall in overall sense actually serving to the purposes of like a sustainability. Thank you everyone.